So deduce that the moment of inertia of a disk about its diameter is a quarter mr squared. Now, just a quick bit about the language there. Okay, so if you imagine I had an ellipse like so, then I had a second ellipse to like almost like a CD. Okay, perpendicular axis theorem. Now, if that's a complete not perpendicular axis term, basically if I rotate it like a CD about this axis, so it's rotating like this, okay, there you are. Okay, so this one is rotating like this, okay, everybody happy enough with that? That moment of inertia is what? When it's rotating through there is a half mr squared, okay. That's through its axis, through the center, perpendicular to the plane of the CD, or plane of the circle. Okay? And that would work if we were rotating like this. It would be parallel to the axis of rotation. However, keywords is what are the keywords in this question? So one or two words change the entire question. Disk about diameter. About the diameter means that I'm going to break up my disk into two parts. I'm going to break it up into two different axes that are perpendicular to the axis I drew previously. So this is the Z axis, this is the X axis, this one's the Y axis. Okay. Now, basically, what's happening here is we can say that IZ by perpendicular axis term is IX plus IY. IZ is a half mr squared. Now, IX and IY are actually the same value of symmetry. Doesn't matter which way you look at it, it's still the same amount of mass, same amount of material. So it's going to be equal to 2 IX. IX therefore equals a quarter mr squared across when you divide down by 2. Hence, that's been proved. Everybody cool with that? Now, unlike previous questions, where I would have a unlike previous questions, come on. There we go. Okay, unlike previous questions, where I might have a rod like so, goes through the middle and out the other side, okay? And actually I'll shift this a bit more over this way. Okay. Usually we're talking about them being parallel to each other straight away. So basically the axis of rotation is parallel to the normal one, the half mr squared IZ. Okay, that's what we're usually talking about. And the whole thing rotates in an ellipse around this point A here. If that was the case, we'd be talking something like this. Everybody got it? But in this question, we're talking more something like this. Okay? Now, what type of language lends itself to, it's not the question that's on the board, but what type of question lends itself to where you're not talking about it being in a horizontal plane like this. I'll just use my parallelogram. You're not talking about it being in this plane here. You're more, which is this plane here is coming out of the board. You're talking about it being in a plane that's the plane of the board itself. So you're talking more like this. Going to get rid of that ellipse, and we're going to replace it with a circle. And instead of the parallelogram, we're going to be talking about instead of the parallelogram, we're going to be talking about a square. Okay? So, like so. That's the plane we're rotating out of, like this. Okay? So, our axis of rotation is actually coming out of the board towards us and back across again. Okay? Because of this, our former IZ is now going into the board. It's now in the wrong direction to the green axis of rotation. It's perpendicular to it, therefore we can't use it. But we already figured out earlier today, in part 2, what is an axis of rotation, what is an axis of inertia parallel to that. Okay? And what it is this. We already broke up IZ that's going into the board. We broke it up into IX and IY, where IX equals a quarter mr squared. And that's parallel with the green axis we're talking about here. Okay? Now, what we're going to do is, first of all, we're going to talk about the point A. The center of gravity of the disk is the distance x from the board. That does not mean it's the midpoint of A to B. There's no proof of that. There's no language to suggest that it's the midpoint of AB in any of the question. And when you highlight, go through the question and highlight, all you can see is also we can see a uniform circular disc of mass has a center C. The word clamped on the rod so that its length AC equals x, and the plane of the disc passes through the axis of rotation. Okay, plane of the disc passes through the axis of rotation. That was that square I was talking about earlier. The disc and the green axis of rotation are both within the square plane. They're both flat on. Okay? So, what that means is, now established that the two of these axes are parallel to each other. Now we just got to find out what's the rod around A. So the rod is held at its end. So that is the rod. And this is inertia about A. Now usually a rod held at its end is 4/3 ml squared. What's the mass of this rod? The mass of this rod is m. So it's 4/3 m. The rod's length is 2a. 2a instead of 2l means replace L with A. So 4/3 ma cubed. Is that okay? Oh, sorry, ma squared. Right, ma squared. Now, that's the rod sorted, okay? Now we got to get the IX value through the center of the circle, or the disc. Okay, so the disc IA, it's usually a quarter mr squared because we're talking about its diameter coming out of the board through its center. Quarter mr squared. Now what's the m value of this disc? It's 24m over 4. The m value is 24. What's the disk's A value? Says up the top its radius value is A over 3. So we're going to change that into A over 3 to squared. Are we happy with that? Now that's done, what we're going to do next is IA equals, put that into the calculator, get 2 ma squared all over 3. Okay. Now, we have to do the parallel axis theorem. One problem with the disk, guys, okay? The disk isn't IA. The disk is IC. Remember we said it's going through the C axis. So this here shouldn't be in an A. Should be in a C. IC, IC. Now we've got to do the parallel axis theorem where I equals IA equals IC plus MD squared. IA is its inertia about A. Its IC value is 2 MA squared over 3. Its MD squared value is 24 MX squared. Please remember that it's a distance x away from IA. Yes. This here. A over 3 squared is the radius. So it comes from a quarter m r squared, where the radius, it says up here, the radius is a over 3, and the m value is 24m. Alright? I'm adding them together to find out what I total is around a. So I total, oh sorry, still haven't found IA of the disk. Still on IA of the disk. IA of the disk is going to be, it's the two of them added together. What is the two of them added together? It's going to be 74 MA squared over 3. I total is the combination of your disk and your rod. Disk and the rod would imply, where's the disk? The rod is here, the disk is here. We're going to add them together, and what are we going to get there? An M. Oh, sorry guys, excuse me. We couldn't add the two of them together that time because it's x squared and a squared. So I was actually blocked by this and this being completely different to each other. So that was my fault. So what we're going to do now is we're going to add this part here to this part here. 4 over 3 plus 2 over 3 MA squared gives me 2 MA squared plus 24 MX squared. I'm going to factorize that. I'm going to get 2m into a squared plus 12x squared. That's my total about a. Okay, about that. Now, what I got to do next, I've proved part 1. Part 1. Yeah. Part 1 is show that the momentum of inertia of the system about the axis is this much here. Okay, so that part is done. Don't need to worry about that anymore. The system makes small oscillations at the period and show that the period is a minimum when x equals a over 4. Straight away you're talking about minimum time. So you're going to have to get the period of your t equals 2 pi your inertia over mgh. Please remember, h is the distance of the center of gravity of your compound system to the axis of rotation. So, on a really basic level, green line represents axis of rotation. We'll go for the black line here. Represents your rod, and then this is my disc that's clamped on, and this is A, and we're rotating out of the board like that, in and out, in and out, in and out. Okay, center of gravity of the disc is how far away? Center of gravity of the disc is x away. 24 mg going straight down. Now, how far is the center of gravity of the rod? We can call it, it's a total length of 2a, so we can call it a length a. What weight's the rod again? mg. Okay? Next, we treat the full system as a compound body. Once again, go axis of rotation through A, through this body. It now has a new center of gravity somewhere in between the green and the somewhere. We'll have it. The total weight of the system being 25 mg, correct? 25 mg. And by definition, h is the distance of the center of gravity of your compound body from the axis of rotation A, so shown by the green line. Now, Let's do turning moments. The turning moments got to be the same. So it's going to be mg a plus 24 mg times x equals 25 mg h. M and G's can completely disappear. And then we're going to find out that h equals a plus 24x all over 25. Everybody happy with that? Okay. So all this work here now disappear off. And so can that. Okay. I found out my h value straight away. H value goes up here. Now, what we're going to do next is we got to substitute in t equals 2 pi, big square root sign, going to need it. The I value is 2m bracket a squared plus 12x squared. On the bottom we're going to have m. Now, that's the other one, isn't it, guys? What do I always do here by mistake? Forget to add the total mass to the compound body. I often put m in there. It's not m. What is it? 25m. It's the mass of the compound body. So what we're looking at here is 25m. Talking about your g there. And now our h value, a plus 24x all over 25. Lucky for us, those 25s will cancel, those m's will cancel, and we're going to be left with t equals 2 pi square root of what's it? I'm going to multiply that in again. I don't know why I factorized it in the first place. All over the a plus the g in there as well. I'm going to take the g out later on. Actually, wait a minute. Leave it the way it was. I don't know why we're going to do that. 2 into a squared plus 12x squared. G into a plus 24x. Now, we're talking about the minimum time, which in theory means that we differentiate a function, we find its turning point, and then following finding its turning point, we do the second derivative to check if it's a maximum or a minimum. The deal is, though, that the maximum and minimum, or the turning points for t, are actually the same turning points for t squared. So what we can do is we can factorize out this here. Now, there's a constant part and there's a differentiable part. The differentiable part is highlighted in green, or sorry, yellow, and the constants are highlighted in blue. This means we can think of a new letter, any letter of your choosing that hasn't been used yet. We'll call it K, alright? Go figure. K is equal to a plus 12x squared, a plus 24x. K has the same turning points as t. It has the same values for maximum and minimum as the t, the periodic time. So we're going to differentiate once. Dk dx using the quotient rule. Okay? So, u dx is 24x. v dx also 24x. So, phi times the u dx is the second one. Now, 24, not 24x, because yeah, it's that part there. Now, what we're doing here is v times the u dx minus u times the v dx, which is 24 times 12x squared, all over squared. It's not easy, okay? Multiply now. 24x. What's 24? 24? 576? So check it out for me. 576 minus 24a. What's that then? 288 x squared over this thing here. And what's that equal to, guys? 0, doesn't it? Okay. Now, what happens next? Sorry? Move the bottom line. Multiply by minus 1. 288 x squared minus 576 plus 24a bracket x. Oh my god. Okay. The problem there, guys, just quickly here, was this slip up here. That resulted in an x squared, not an x. Okay, so that's a little more complicated than it needs to be. So we just rewind a step. We're going to 288 x squared plus 24ax minus 24a equals 0. Then we're going to get rid of all those 24s we're talking about. Divide by 24. We're going to 12x squared plus 1ax minus a equals 0. How to solve this? Well, you can do the minus b equation, or you can try 3x 4x, and then you're going to try, that's a squared. Where's my a squared gone? An a there. 24a squared. 1 second, guys, making a mistake here. One other thing, guys, back up here from earlier, is that this here was an a squared, makes that 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 an a squared, runs down to making that an a squared. Now, we've done that part, then we're going to solve this, and we get 3x plus a, 4x minus a equals 0. We're going to get two values. We're going to get x equals minus a over 3. Sort of a problem, isn't it? Because it's negative. And the other value is x equals a over 4. And that's, you can say it's the only turning point, so hence here is the minimum when x equals a over 4. Okay. Technically speaking, you could go through the second derivative, and it's probably not a good idea, but leave it there.